have been working in the climate space for quite some time now. And I have to say, it wasn't until the past 5 years or so that I start to realize that more and more people are caring about negative emissions, which is promising. So because, now we're not talking about reaching, stabilizing the emissions, we're talking about achieving negative emissions. To me, that's really a step forward in seriously tackling this global climate challenge.
Welcome to Growing Impact, a podcast by the Institutes of Energy and the Environment at Penn State. Growing Impact explores cutting-edge projects of researchers and scientists who are solving some of the world's most challenging energy and environmental issues. Each project has been funded through an innovative Sea Grant program that is facilitated through IEE. I'm your host, Kevin Slyman. Today on Growing Impact, I speak with Wei Peng, an assistant professor of international affairs and civil and environmental engineering. We are speaking about her project that aims to provide policy and technology leaders with information that will help them determine what decarbonization technologies might be effective in the future and how to strategically employ those technologies.
Welcome to Growing Impact. Today we're speaking with Wei Peng, and we're discussing her project From Local Health to Global Climate, assessing the impacts of early adoption on future landscape of negative emissions technologies. Welcome to the episode, Wei.
It's a pleasure to be here.
Let's talk about your project.
So we know that climate change is a global issue, but at the same time, how we use energy and how we tackle climate change is also going to affect local health. So one such example is through, for example, air pollution pathway, or through food-related health risks, et cetera, et cetera. So what we really want to do here is that by understanding what will be the local health implications of this negative emissions technologies, how this local health implications will affect the early adoption of certain technologies, and as a result, changing the future landscape of deploying this technology. So that's really how we want to make this connection between local health and global climate.
So how are you assessing local health?
Yeah, so the way we do it is through what we call integrated assessment modeling. So this is the kind of modeling approach we have done a lot in the past 10 years or so, by linking really an interdisciplinary modeling from different aspects. So we usually start with the future socioeconomic development, the future population patterns, and this will affect how much energy demand people will need. And this will also affect what kind of energy technologies you want to use in order to meet that demand. And then how we use energy and also how we get our food is going to affect the carbon emissions, as well as air polluted emissions, as well as what I mentioned earlier, there's food-related health risks. So the last component of this integrated assessment modeling is to do health impact assessment based on your exposure to air pollution and also the exposure to dietary-related risks.
And so you're trying to understand each one of those and how they flow through each other to ultimately impact emissions.
Exactly. So This is really kind of a key, we would say intellectual contribution we want to make here. In order to really connect all these components like technology, like carbon emissions and health, you really need a systems approach. So you will not be able to just use one model or one data set to answer this question. So what we really want to achieve in this project is to combining all those elements, combining the human system, the technology system, the carbon emissions, and also the health impact, so that we can provide a systemic overview of the whole system and how things interact. And this will have, again, implications on our technology choices, our health future, as well as the climate future.
Okay. So that's the ultimate goal then, is to help inform future decisions.
Yeah. So we really want to inform decision on in this case, the negative emissions technologies, so that we can have this integrated view on health, on climate, and also on cost, like economics.
And with emissions, is it something specific that you're looking at, or is it a broad spectrum of emissions?
Yeah, so we definitely care about carbon emissions. right? See, at the end of the day, carbon emissions is why we have the global warming or climate change problem in the first place. So carbon emissions is definitely one of our focus. But at the same time, as I mentioned, a lot of like energy technology, they not only emit carbon emissions, they also emit air pollutant emissions, such as sulfur dioxide, nitrogen oxide, et cetera, et cetera. So we also focus on those air pollutants as well. And the main reason is that those air pollutants will affect your health. So when they're emitted into the air, they're going to form what we call secondary pollution, such as ozone, such as PM2.5, those like fine particulate matter, so small they can penetrate into your lung and pose health impact. So in addition to carbon emissions, we also capture this kind of air pollutant emissions so that we can really understand the near-term implications on human health. We have been using this model to generate what we call large-scale scenario ensemble. So we generate like 20,000 scenarios so that we can capture a wide range of plausible futures. So there will be, we don't know like how many people will live on the earth in the future. We also don't know like how much energy demand we'll have in the future. If we have another COVID, then things may change as well. So we want to capture a wide range of plausible futures using the scenario ensemble approach. So that's basically where we are.
Wow, 20,000. I mean, that's mind-boggling to think of. So many variables that could be are possible futures. That's astonishing. How, I don't know if this is relevant or not, in the modeling, and maybe that's what you're aiming for, how, I'll use the term reliable, but maybe that's the wrong term, or how predictive is it? Or do you have ideas of how well the modeling can assist in making these decisions?
Yeah, so I think that's a great question. I think most modelers will answer this question by saying, all models are wrong, but some are useful. And I think I would not say we're trying to make predictions for the future. And to be honest with you, I think anyone who says that, we need to question whether or not he or she can actually deliver that. So what we want to do is exactly in addition to say like how confident we are about the future, how about we just take a step back and say that we don't really know. But we know that there are some major uncertainties that will likely shape the plausible futures. So as a result, the approach we are taking is not to tell you that these are the two futures that are most possible to occur. Well, the approach we take is that we think there are, for example, there's 20 factors that are most likely to shape our collective future. And we want to sample all these factors and then just show you those 30,000 plausible futures and see whether or not there will be robust strategies that no matter what uncertainties we will face in the future, they are still the good things to do or good policies to implement today. So I think robust is really the word we want to emphasize here. We want to identify robust strategies that will do well under a wide range of plausible futures.
Can you talk a little bit about your background in it and then the folks that you're surrounding yourself with to help round out the team?
Yeah, definitely. So most of my work has been looking at the air quality and health implications of energy strategies. So that's the thing I've been doing in the past 10 years. So I do things like air quality modeling, emissions scenarios. I do health impact assessment. So that's kind of like the academic work I've been working on in the past decade. And that's definitely not enough, right? As you can hear that I'm talking about a few keywords of our title, but not all of them. So I have been really enjoying this collaboration with my co-PI, Dr. Klaus Keller, who's professor in the Department of Geosciences. He's really an expert on robust decision making. So this is where this like word robust comes into the proposal and comes into our work. So with his help, what we have been really thinking hard about is how to design that, how to sample uncertainties in a, on the one hand, practical, and on the other hand, important way. And at the same time, after we have this like 30,000 plausible futures, what kind of methodologies or what kind of insights we can get out of it. So this is really kind of like a sweet spot where like I have been really looking at the methodology or the issue connecting energy, health, and climate. And he has been really looking at looking at, for example, the uncertainty characterization and how should we think about robust strategy, given that nobody really know what kind of future we'll end up with in the end.
What kind of either organizations or individuals do you hope to help educate, inform, or raise awareness with this information? Who do you hope to deliver this to, and who could it impact?
Yeah, that's a great question. So I think what we do is really policy relevant research. So just give you some example. I think now in the United States, so Biden has done really interesting stuff already about the infrastructure plan, et cetera, et cetera. But in addition to all those exciting stuff now happening at the federal level, what we have been observing in the past 5 to 10 years is that a lot of climate action is going local. And for example, State College, and Penn State University, we do have a lot of like climate action that we are thinking about doing locally. So the emphasis on local health is really the how we want to connect with those local and regional decision makers. Because health is the thing that people care a lot about. And we know that climate change need collective action from everyone in all the locations and also internationally. So I think the targeted audience of our work is really these local decision makers who hopefully care about the global climate change, but at the same time, they care so much about the health of their local communities. So what we want to emphasize here, using the research and insight from our work, is whether or not we can find those sweet spots where for local decision makers, they can really generate the local health benefits, but at the same time contributing to this global efforts of tackling climate change. So I think they are our targeted audiences, like in the policy space. I also think that we haven't talked much about the technology aspect, but when we're thinking about things like negative emissions technologies, there are a lot of different potential technologies that can deliver negative emissions. There are technologies that we have been doing for a very long time, such as afforestation. Because when you plant trees, when they grow, they draw CO2 from the atmosphere. So that's kind of like the thing we have been doing for a long time. There are also other technologies that there are components of them that we know how to do it, but not the other parts. And in this category, the example is bioenergy with carbon capture and storage. So this is an integrated technology system. What we know is we know how to produce biofuel, but we don't really, but till now, we're not very good at doing carbon capture and storage, the CCS part. So this is a kind of technology BECCS that there are certain components that is already commercialized, but there are certain components such as CCS, we're still struggling to make it a commercializable technology. So this is the second type of technology. And there is a third type of technology that is still really, really early, such as direct air capture. So that's the idea of you directly absorb CO2 from the atmosphere. Right now, there are people like really using very creative methods to think about how can we do that. But I have to say, this is really still at the experiment and research stage. So as you could, you probably have already recognized, we have different technologies that we could potentially use to reach negative emissions, and they are at different readiness level, and they have different cost. So when you're thinking about which technology you want to invest, and as a policymaker, you have limited funding. And as a technologist, you probably want to be strategic in terms of what technology you want to invest today so that you can secure your market in the future. So I think another targeted audience we were thinking about is those people who are interested in negative emissions technologies and their potential futures. So what we want to really understand here is that because health is important, you could imagine that those negative emissions technologies that have health co-benefits, people may like it better. People may want to deploy them earlier. As a result, if you choose certain technologies to deploy today, it may make them cheaper and more competitive in the future So we are actually, to some extent, help picking the winners for the future landscape of the negative emissions technologies. So I think this is kind of like the second type of audience we hope to reach, those people who are looking at what kind of negative emissions technologies the society will depend on in the future, and also how should we be strategic in choosing and investing certain technologies.
That is a heavy burden.
I know, yeah. That's what keeps me awake at night sometimes.
Yeah, it is. I mean, it's important work that needs to be done, but you're right. If investing in a certain, go in a certain direction, and then we start choosing those technologies, and so there's a lot
hard.
to it. There's a lot at stake. So.
This is also the reason why, remember we talked about this, like a wide range of plausible futures. This is also why I think that dynamic perspective and robustness perspective is critical, right? Because like what you do today is going to affect what will become competitive in the future. So that's why, we don't just want to tell you this is like one predictive future. We want to let you know that, for example, if you decide to invest in bioenergy with carbon capture and storage today, because they can bring certain, for example, health co-benefits, then this will affect what will be the better strategy for you like 5 or 10 years or even 50 years from now. So that robust and dynamic perspective is what we want to add to the literature in this space.
Thank you for listening to Growing Impact. Today on our episode, we spoke with Wei Peng, and we discussed her project From Local Health to Global Climate, Assessing the Impacts of Early Adoption on Future Landscape of Negative Emissions Technologies. Thank you for being here, Wei.
Thank you for the opportunity to chat with you.
You are very welcome. Thank you for taking time.
You have been listening to Growing Impact, a podcast by the Institutes of Energy and the Environment at Penn State. I've been your host, Kevin Slyman. This has been Season 1, Episode 5. Thank you for listening.